Hello and welcome to this AI Patterns coffee break. Wonderful. Nice that you are here. Today's coffee break is about quite recent decision of the European Patent Office about a digital patent, which I find quite interesting and which I wanted to share with you. The story goes something like this, that you could imagine for a second that you are let's say, an automotive engineer, and let's say you are developing new kinds of chassis shapes for cars, to make them more efficient and more rigid, and at the same time have the chassis so that fuel is can be saved, things like that. Typical things that engineers work on, right? And of course, you don't want to build hundreds of very expensive prototypes, but of course, you have software today, AI, simulation software, where you can model these kinds of problems, and then have some very clever optimization algorithms who then spit out, let's say, the perfect chassis shape for the job, right? So that's the overall context of this software invention, and let's find out how the European Patent Office deals with these kinds of inventions, right? So the patent application I'm talking about today is actually filed by not really an automotive manufacturer, but one of the large steel producers. Actually, the applicant is a company called JFE Steel, which is the second largest steel producer in Japan after Nippon Steel, which is the largest one in Japan. I just looked them up on the internet, and this is one of the image videos you can find on YouTube. So this is what this company is doing. As you can see, this is really hard technical stuff, engineering, power plants, natural resources, heavy equipment, you name it. So every boy's a dream, basically. So that's what JFE Steel is doing. And as I was saying already, so this patent application is not really about real steel and real machinery in the real world, but about optimization software for automotive chassis in the end. So let's look into the patent application at hand. Here's the PDF of the patent application as it was published. So the title of this application is Shape Optimization Analyzing Method and Apparatus, therefore. And so the overall goal, as I said, is to optimize the shape of a 3D model of an automotive steel sheet structure. So this invention, just to make it clear, is not about really actually producing the automotive steel sheet structure. So not about making the real chassis in the real world, but the invention is about having a digital model of the chassis, and then using a certain clever algorithm to optimize this digital model of the real world chassis. So the invention takes place purely within the computer in the digital realm, so to say. So the goal is to optimize the shape of a model of an automotive steel sheet structure. How does it work? So the patent claim, which defines the actual scope of protection, is a bit lengthy. So let's just maybe look at figure 1 here, and I'll give you an executive summary of what's in the claim. So the solution is roughly as follows. So first of all, what is defined is a so-called structure model here in a model file. And this kind of structure model, you can think of it as, here some kind of wireframe model of a car chassis. You can see that here, although a digital one, right? It's a model. So it's some kind of digital representation which defines the overall shape of a car chassis. And this how is it called? Structure model defines, let's say, the design space, the overall design space in which the invention takes place. So then, secondly, we have a so-called block model here, a block model generating unit which generates this block model. And the block model is some kind of a mesh consisting of 3D block elements. So you can also see that in the other pictures, in that inside this overall structural model, there is this block model here, the darker one, embedded. So this is a very simple block model. Of course, it consists of small, tiny 3D objects. I think you can see it in one of the pictures. Oh, I can't find the right picture right now. Yeah, you can see that exactly here. The overall block model here consists of 3D shapes, individual shapes. And in the beginning, of course, this is a very, very simplistic block model. And then, thanks to the algorithmic optimization, the calculations that take place, this initially very simplistic block model is then optimized and the shape is changed. And in the end, you could obtain something like that here, which is then a design for the final part here of the chassis. Of course, not any kind of chassis is calculated here, but should be an optimal one, of course. And to determine what optimal means in this respect, an operator, a human being, can input a so-called analytic condition. And this analytic condition can be either some kind of constraint for the design. So, for example, a position where a load is applied to the structure, or it can be a goal of the optimization. So, for example, please maximize the rigidity of the structure, okay? Or please minimize the amount of material we have to use. Okay, and so then once you have all those digital models, and once you have the analytic condition defined, then you can run the algorithm, and by way of some numeric calculations, then some kind of final and hopefully optimal design is then created. And finally, in the patent claim, the last step is then that this calculated optimal shape is then displayed on a monitor. So that's the output of the method, an hopefully optimal structure here displayed on a computer device. So what happened in first instance? Well, maybe just as a general remark for those of you who are not so familiar with the European patent system. So what happens is, initially when you file a patent application, it lands on the desk of one of the, I think, 7,000 examiners at the European Patent Office. And then typical patent prosecution procedure takes place, some written back and forth, and then maybe an oral proceedings, as in this case. In the oral proceedings, in the hearing, you have 3 examiners you're dealing with. And if those 3 examiners cannot be convinced to grant a patent, they will refuse the patent application. And then, as the applicant, then you can go on appeal and appeal against the refusal of the patent application. And then the whole case is heard by a different panel on the second instance, by the so-called boards of appeal of the European Patent Office. Those boards of appeal then render a decision, and that's the case law we have in Europe then. And this is one of those cases. So in the first instance, the patent examiner refused the patent application based on mainly the reasoning of G1 of 19, one of the landmark decisions for simulation methods. And the main argument was that, well, the whole design activity takes place on a representation of an automotive steel sheet structure, right, on a digital model. And so there was no technical effect, because a technical effect would only be created if, for example, the automotive steel sheet structure would actually been built in the end. That would then be a technical effect in the real world, so to say. But as long as you are only operating on a model, on a digital model, on a pure digital representation of the real life entity, you are not in the field of technology. You are in the in the digital abstract realm, and you don't create a technical effect in the real world, so to say. And then, as a conclusion, then the typical reasoning applied by the European Patent Office then applies. So if most of what's in the claim is non-technical, then and the only technical feature is a well-known computer, then implementing the non-technical method on a well-known computer is obvious, and so the application was refused for lack of inventive step. That's how the European Patent Office typically deals with these kinds of applications. So generally speaking, as we're talking here, so if you have any questions, any comments during my talk here, feel free to put it in the chat, right? We can have a small Q&A maybe at the end of this video. Okay, so in first instance, the patent application was refused for the reasons I just summarized, and then the applicant went on appeal, more or less with the same requests. And now let's see how the Board of Appeal then finally ruled on this case, right? So let's look into the decision. This is what a Board of Appeal decision looks like. So you have the data sheet with the bibliographic data, and then it first always starts with a summary of the facts and submissions. So what happened in first instance, what are the requests on file, and so on. But I would say we jump right into the reasons for the decision now. So on inventive step, first of all, the Board of Appeal repeats or summarizes its understanding of Claim 1. That's what I just explained. And then here it really starts. So the Board of Appeal says, Claim 1 is a computer-implemented method which allows a user to input certain data, carries out a calculation, and displays the result of the calculation. The method can be implemented by suitably programming a well-known conventional computer having conventional display and input devices. And people who know how the EPO thinks about these things maybe already know where this is going. So, but this is, I think, interesting to know. So this is a typical way how the Boards of Appeal nowadays look at digital inventions, and especially how they look at simulation and design software. They don't ask too much about what actually is the purpose of the whole exercise. So here in this paragraph, it doesn't play any role that the overall goal is to optimize the shape of a technical thing, right, of a car chassis. But they look at these kinds of inventions purely more or less from an input-output perspective, right? They say, okay, there is certain data user input going in, that's data. There's some calculation carried out, and then a result of the calculation is displayed. And then they go on and say, hence, the subject matter of Claim 1 differs from such a well-known conventional computer in the computer program that it runs. Fair enough. This computer program can contribute to an inventive step only to the extent that it achieves a technical effect going beyond the normal functioning of a conventional computer. That's, so to say, the general approach to software inventions, or to computer implemented inventions as they are officially called. So as soon as the inventive part lies within the software, you have to ask yourself, what does the software do? Does it serve a technical effect? Then it is, so to say, technical software which can contribute to inventive step. And if it only solves a non-technical problem, if it doesn't create a technical effect, then it is software as such which does not contribute to inventive step. So going further, the Board of Appeal then defines or lays out what can be technical effects in the field of software. And they say, and this is important, technical effects can occur, in particular, within the computer implemented process, in the form of specific adaptations of the program to the hardware of the computer, or at the input and output of this process. And here they cite the landmark decision I was mentioning earlier, G1 of 19, especially point 85. Let's have a look into that because that's a central part of G1 of 19 where the enlarged Board of Appeals, or the highest judicial instance of the European patent system, has even drawn up a little sketch here how they see these things. And here you can see again that these are the places where, according to the enlarged Board of Appeal of the European Patent Office, where technical effects can typically occur in a computer implemented process. And they say, well, technical effects can occur inside the program, insofar as the program is really specifically adapted to the hardware on which it runs, on the input or on the output. That's where we have to hunt for technical effects, so to say. And well, that's then what the Technical Board of Appeal really does in this decision. They just now go one by one through these three, let's say, places where technical effects can potentially be found. And then they say, firstly, with respect to the input side, since Claim 1 does not define any specific data input mechanism, and since the input data is provided by a user, remember, the input data is either the condition to be optimized or the models on which the whole simulation runs. All of that is digital and is user provided. Since this is the case, the board cannot identify a technical effect going beyond the normal functioning of a conventional computer at the input of the method. So, point made with respect to the first potential place where technical effects can take place, namely at the input side. No technical effect here, according to the board. Then they go on. The appellant argued that the block model generating and coupling steps of Claim 1 represented specific adaptations of the program to a computer as they implemented real-world requirements relating to steel sheets. So here, the appellant, the patent applicant, tried to argue that there is a technical effect going on inside the computer, and that the software is specifically adapted to the hardware on which it runs. However, also this argument is not bought by the Board of Appeal. They say basically, no, well, it does not amount. What do they say exactly? The block model generating and coupling steps, as well as the other steps, are defined at a purely algorithmic level and do not reflect any technical considerations relating to the functioning of the hardware on which the computer program is run. So that's a problem with this one of the three places where technical effects can potentially be found. It's really about hardware invention. So only if the invention is rather algorithmic on a logical algorithmic level, you cannot make a point here normally, but you would need really a specific hardware technical low-level implementation. So, for example, if you, I don't know, if you divide up your data into certain chunks that are divided in such a way that they particularly fit into, the register of the CPU, of a special CPU with a special instruction set, that would be one of those inventions, but not here. So also the second place where technical effects can be found, not here, unfortunately. And then as to the third one, the board says, as to technical effects at the output of the computer implemented method, the board notes that the claimed method merely displays the calculation result of the optimal shape as a design of the automotive steel sheet structure on a conventional display device. And the mere displaying also is not enough for the boards of appeal to create a real technical effect. They say that the calculation result itself, which is displayed, is just data and does not in itself represent a technical effect. Again, citing G1 of 19. So, and that's basically the core of this decision, the core of the reasons of the Board of Appeal. So they really just go through these three places where technical effects can potentially be found, either at the input side, uh, during the processing, insofar as the processing is adapted to the hardware specifically, and the output of the method. And in neither of these three places they could found a technical effect in that in this case, because, well, the input of the design process here, of the claimed design process, is digital models and user constraints. Then there is some algorithmic processing going on, and then there is just data displayed on a display, and none of these steps are technical in themselves for the boards of appeal. Okay, looking at the time, I think this is basically the main points of the decision. One interesting other point for me was that the applicant here, the appellant, also requested that a referral question should be submitted to the enlarged Board of Appeal. That can happen sometimes if in very special cases where either let's say the uniform application of the law, so to say, is at stake, and if there are diverging decisions, for example, which need to be resolved and clarified by the enlarged board. And so here the applicant said that there is one question which should be asked to the enlarged Board of Appeal, and that question was, is it sufficient? So that's the formulation, the suggested question suggested by the applicant. Is it sufficient to confer technicality to a claim directed to a computer-assisted design method that the claim specifies that data calculated by the computer is adapted for being reflected on a physical, tangible component? So that's what the appellant wanted to have an answer on. Also here, the Board of Appeal did not admit this question, this referrer, because they said, well, there is basically no divergence in the case law, and our reasoning is just in line with G1 of 19, and therefore there was no reason to refer this question to the enlarged Board of Appeal. So also this request was refused. In the end, the appeal was dismissed, and so the application stayed refused, and no software patent was granted. So let's think about possible ways out, maybe. So what could the applicant have done differently to maybe obtain another result? Always difficult to say, because I mean, this patent application was written long before G1 of 19 came into place, and things were quite easier at that time. But I mean, in retrospective, what is always helpful, and what I always try to incorporate in the patent application I'm drafting myself, is well, to have enough material already in the patent application as filed, as I'm drafting it, for these three places where potential technical effects can happen. So if you are talking, and that is now some kind of tip for my fellow patent attorneys. So if you are talking to inventors about such a simulation or design invention, ask them, maybe is the software, maybe it is in some sense specifically adapted to the hardware in which it runs. Sometimes it's the case. For example, let's look at, I don't know, AI inventions, artificial intelligence and machine learning. One big problem out, or one hot topic out there is, for example, LLM quantization. So, which means taking a large language model, which is very large, which has maybe, I don't know, there are models out there with, let's say, 7 billion parameters, and then there's some clever kind of algorithms which are called quantization mechanisms, which kind of compress down those models to make them smaller, to take them from, let's say, 7 billion parameters to only, let's say, 1.3 parameters, without or with an acceptable loss of quality, right? So that would be a really a technical topic within this whole AI field, because here it is really about making the model smaller, right? In terms of storage capacity. And generally speaking, yeah, G1 of 19 also lists explicitly these technical effects of, you know, better use of storage capacity or network bandwidth. If you have something there, then you can have a technical invention within the fact how the software is actually adapted to the hardware in which it runs. And then, of course, we have the question, are there technical effects on the output side? Here, what would have helped, obviously, is to have in the method claim, in the patent claim, the last step as a production step. So a step which actually produces an automotive steel sheet structure based on the optimal design, right? Then all the problems would have basically gone away, all the patentability problems, because then you would have that real technical effect in the real world, because you are producing a steel sheet structure in the real world as part of the claim, and therefore also the whole optimization inherits the technical character of that, so to say. On the other hand, such a claim is often not wanted by applicants from an infringement perspective, because if you are only selling such a design tool, of course, you need not be the one who also produces the actual steel sheet structure. So you would have indirect infringement only. But hey, better than nothing, right? So including a production step in the claim is always the safe bank, the safe bet, so to say, and at least you should have it as a potential fallback position in your patent application. Another idea I'm pondering right now, and which I'm also including in my patent applications, is having the let's say the intended use explicitly in the claim. So that's one point the boards of appeal seem to stress very much, is that the at least the intended use of the method must be technical and must be explicitly defined. And so one idea would be to maybe have something in the claim, and at least as a fallback position in the description, something like displaying the calculation result for use in a production process of an automotive steel sheet structure. So there you would have the intended use of the whole calculation result in the claim without really requiring the physical production process. So maybe that would also help. And then, of course, you can have the technical effect on the input side. In this case, I don't see really many chances to have that here, because, I mean, hey, it's a simulation method, a design method, and that starts with a model, and that doesn't start with real measurements typically, right? Okay, so hopefully that's somewhat helpful when you are drafting patent applications in this exciting field. Let's briefly look at the end into the other jurisdictions in this patent family. So I was looking into Espacenet, and I saw that there was a patent granted in the US, actually. And I was smiling a bit when I saw that, because that's a situation I encounter often, I have to say, because it's just oftentimes the case that the European part of such a patent family is refused for reasons similar as those we discussed today. but the US counterpart is granted with more or less no problems. In this case, it's a little bit special because in this case, the US patent has in claim 1 actually has a structure forming step where the real physical steel sheet structure is actually formed, is actually produced. So in the US, they incorporated that into the claim and got the patent. In Europe, at the European Patent Office, the European examiner took the view that such a step is not disclosed in the application, so they didn't get to that. And we also have patent grants for this case in China and in Korea, so it seems like JFE Steel was successful in basically in every jurisdiction they went at, except for Europe, unfortunately. Okay, so I hope this gives you an idea of how the EPO is thinking about design and simulation software right now and the patentability of those kinds of inventions. If you like these kinds of case law walkthroughs, let me know, and we can do more of that, of course. Also, please do me a favor and share this video with your colleagues. And that's it for now. Thanks, and see you in the next one.